a second ago, 3 plus 4 plus 5. If I take that and divide by 2, we can split that, right, into 3 fractions. But you can't do it the other way around, right? If you have this does not become 2/3 plus 2/4 plus 2/5. That is not allowed. You can only do it the other way around. So I'm stuck here. Like this is not going to happen, all right? So on your test, what you should be looking for, if I'm going to try and give you a problem like this, is to see some sort of polynomial up here or some sort of like a bunch of x's and a single term in the bottom. That should be like, boom, I need to split this up, all right? Now, will we be able to do this? Yes, but just not yet. We're just not ready for this yet, all right? I'm going to have to give you a new rule for that, and that will come next class, all right? I'm going to go on to the next. It's not a rule, it's just a fact. Right now, we can take the derivative of x to powers, right? I'm going to recap everything over here on the side. You know how I've been using this notation, f with the little prime mark, right? That meant derivative. Okay, watch how I do this over here. I'm just going to recap what we've done. Recap, all right? If I take a constant, right, a constant, and I take its derivative, I get 0. Does that make sense to you, if I write it like that? If I take x, and I take its derivative, I just get 1, right? If I take x to the n, and I take its derivative, I get n x to the n minus 1, all right? And then the others are just that you can add and subtract. All of these formulas are on your formula sheets, okay? They're there. Does anyone have them with you by chance? See, may I? So on your formula sheets, if you go to reference page 5 on your formula sheets, at the very top, it summarizes these formulas. So if for any reason during a test you freak out, blank, can't remember, these are here, all right? I just want you to know that. All right, so that's where we are. Now, we're going to look at the derivative of some other types of functions, because right now the only thing we can handle is x to a power. Really, that's the only thing we can handle. But how about another function that we've studied? How about the sine function? We studied that in pre-cal, right? Wouldn't it be nice if we could figure out what the derivative of that was? Right? Figure it out? Well, I could go through the whole long thing. Do I or no? Do y'all want to see? Do you want me to prove what the derivative of sine is or no? I'm seeing a lot of no's. No? Okay. If you did it with the limit, it would require that you use a double angle formula from pre-cal and do some algebraic simplification. It works. It's not too bad, but if you don't want to see it, we'll move on, all right? So I'm just going to tell you this. You're going to say, okay, I believe you, and we leave it at that. The derivative of the sine function is exactly the cosine function. That's it. The derivative of sine of x is cosine x. Now, I'm not going to prove it to you, but I'm going to show it to you visually. So I'm going to graph here sine x for you. There's sine x. Let me zoom in here. And we talked about this in class last time, so I know this is not brand new. If I ask you to do what we did last class, which is if this is the graph of f, right? We're looking at f here in red. If I ask you to graph its derivative, what you would do is say, okay, well, hold on, let me see. If I'm going to graph the derivative, let me see the points I know. Like I know here the derivative is 0, right? Slope of tangent line 0 there. Slope of tangent line 0 here. Do y'all remember me doing this last class? So I know if I graph the derivative, I'm going to have a 0 here, have a 0 here, have a 0 here. And then I also think that right about here, at this point, it looks like the slope of my tangent line is 1. So I'm going to put a 1 there. And it looks like about right here, the slope of the tangent line is -1, so I'm going to put a -1 there. And then I could play that game where I'm like, okay, the slope is positive, but small, getting bigger, 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 and then it goes back to 0. I could do all that, and when I do it, it would connect together, and I would get exactly the cosine function, right? It's exactly the cosine function. That's kind of cool, right? So derivative sine of x is cosine x. That's it. All right, what do you think I'm gonna ask now? If the derivative of sine of x is cosine of x, then what's the derivative of cosine of x, right? What's the derivative of cosine of x? So let me take the sine off of here, and let's start this whole game over. Let's act like this is the function I'm giving you to start. Okay, if this is cosine x here, and I ask you to graph its derivative, let's go to the places where we know the derivative is 0. Here, and here, right? And over here. So that means when I graph its derivative, it'll have a point here on the x-axis, here, and here. About right here, the slope of the tangent line is about -1, so I'm going to put a -1 here. About right here, the slope is +1, so I'm going to put a point here. Does that look like the sine function to you? If I go like this? No, that's not the sine function. But it's close to it. Here's sine. Let me graph sine. There's sine. There's what we're getting. So what do you think it is? It's negative sine. It's the sine function flipped over. So if I take this, let me change it to negative sine. Now you see that matches up with the derivative. So that's the next result. Where are they? Oh, I'm in the wrong place. So the derivative of sine of x, we did that. Derivative of sine of x is cosine of x. But the derivative of cosine of x is negative sine x, not positive sine. Wouldn't it be nice if it was not negative? If it was just derivative of sine is cosine, derivative of cosine is sine. But that's not the case. Yes?
Is it just like 1 over sine of x then? Or would that not make sense?
1 over, what is what?
Where I'm trying to say like negative sine of x would equal 1 over sine of x.
No, this is -1 times sine of x, not sine of x to the -1. That would be 1 over sine of x. I'm not sure if that's what you're saying,
Yeah.
right? And 1 over sine in pre-cal, 1 divided by sine is actually cosecant, right? That's a cosecant function. So this is just, remember in pre-cal, the number in front gave you like the amplitude, and it also told you whether or not you had flipping or not going on. So this is just saying, hey, take the sine function, has an amplitude of 1, and then flip it over the x-axis. That's all that is. So we know how to handle now the derivative of x to a power. We know that the derivative of sine of x is cosine x. We know that the derivative of cosine of x is sine x. Okay? That's what we know. Sorry. There's going to be a place in math purgatory when I get there. And they're going to bring up all these little stupid things I did. And remember this? You forgot negative? Yeah, that's negative. All right? What do you think we're going to go after now? Tangent, right? Might be worth it to figure out what the derivative of tangent is. Now, I'm not going to do it graphically. I'm not going to do it graphically. I'm just going to tell you what it is, all right? The derivative of tangent is secant squared x. Yeah, it's not, you weren't expecting that, were you? Right? That doesn't seem to be, like, derivative of sine was cosine. Derivative of cosine was negative sine. Everything's nice and clean. And then you get derivative of tangent, it's secant squared x. My advice to you, as a student who's going to need Cal 2 at some point, right, most of you, is that you need to have those three memorized. Without a doubt, you have to have those three memorized, right? You have to. The next three, you should know the derivatives, and if you can memorize them, that would be even better. But at least know that where they are on your formula sheets. The derivative of cosecant x is negative cosecant x cotangent x. The derivative of secant x is secant x tangent x, and the derivative of cotangent x is negative cosecant squared x. They are all on your formula sheets, all right? They're all there. I actually have the formula sheets here. I forgot I had them up. Let me show you. Reference page 5. Okay, so we did this. The derivative of a constant is 0. We did that when you add and subtract things together, you can separate them, do them separately. We did this one. This is the one that says the constant comes for the ride. We did this one right here. This is the power rule. We did that. Okay, that's the almighty power rule. We have yet to talk about the product rule, the quotient rule, and the chain rule. Those are going to come next classes, and they are going to get progressively more difficult. The chain rule is going to be the difference between you becoming an engineer or a computer scientist or not. If you don't understand chain rule, the road of calculus will end for you. All right? I'm only telling you that. Be ready for it because it's one of those. It's a light bulb idea. It's one of those things where, like I've told you, it's like you click, it clicks, and you're good to go, right? But when it doesn't click, it's a nightmare. So we will spend a lot of time on chain rule. All right, so that we've got. Now if you scroll down, you'll see here the trigonometric functions. We just talked about the derivative of sine is cosine, derivative of cosine is negative sine, derivative of tangent is secant squared. See, they're all here. All 6 of them are here. Okay, I didn't mean that in a mean way. I'm just trying to be honest with you, right? When we get to chain rule, if you can't get chain rule, then it's impossible to do this class after that. All right, everything else depends on the chain rule. Yes. Yeah. Yeah, you can get away, like that section that we did last time where I draw the function and you draw me the derivative. If that never clicks for you, it might hinder you a little bit, but it's not going to make you not be an engineer one day. You know what I mean? Like you'll figure that out at some point. But if you can't do chain rule, that's like me telling you to go like run a race and I chain you to a tree. You know what I mean? Like you're not going to be able to do it. So. Okay. See, those are the next 2 sections. Let's do this. Let's do an example here. Let's find the derivative of this function. So if I'm going to find the derivative of this function, the very first thing I'm going to notice is that I've got subtraction and addition. I have 3 terms, right? Those are 3 terms. There's a rule that we've established that if you have terms, you can differentiate each term individually, right? So let me start with this first one. On this first one, I have a constant times a function, right? It's 5 times sine x. So when I take derivative of this, the 5 is not going to become a 0. It's going to come for the ride, right? It's going to come and just be in front. So I'm going to have the 5 comes down for the ride. And now what I do is just look at the other piece, the sine x, and take its derivative. What's the derivative of sine x? Cosine x. Okay. So 5 times cosine x, so far, that's where I am. Now I have a minus sign. And then same thing, this 3 is attached to the cosine through multiplication. So that 3 is going to come for the ride. So minus 3. And now be careful here, because now you need to take derivative of cosine x, which is minus sine x. Now, I have to be careful how I write this, because I'm taking this number 3 and I'm multiplying by negative sign, right? So I don't want to write this. I don't want to write minus sine x, because that will look like I mean like subtraction, right? I want to write something like this. I want to write parentheses negative sine x. That way you know that I'm multiplying these two together. Then I have a plus. It comes down, and then I have the 5 attached to the tangent. The 5 will come for the ride, and then I just say, hey, what's the derivative of tangent x? Secant squared x. Secant squared x. Remember, everybody, secant squared x means secant x to the second power. Those two things are equivalent, right? When it comes to notation for our trig functions, that's what this means. I'm just pointing it out. It's not necessary that you know that, or we don't need that information for this. I just want you to remember what it means. Okay? And then we could clean this up a little bit. We could just write like 5 cosine x, and then these together, two negatives become a plus 3 sine x, and then plus 5 secant squared x. That's it. We box it up. That's our derivative. I'm going to put something different on the board. Okay, I'm going to put this on the board. And I'm going to ask you for this. So the purpose of this question is to show you different notation, all right? So that you don't freak out when you do your homework and you see different variables, different letters. Everything I've done up to this point, I've just been using x, 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 right? And I've been saying, hey, go find me f prime of x, right? All these problems I've been saying, hey, go get me this, right? Go get me this, go get me this. Well, now, I'm not going to use that notation. I'm going to write an equation down, y equals theta squared over 5 minus 5 over theta. And I'm going to ask you, this is basically asking you to find the derivative of this y, of this equation for y, treating theta like your variable. This down here tells you what's your variable in the problem. So here, theta's like x, okay? Theta's like x. And I just want to know what that is, the derivative. So I'm going to write down here, dy d theta is, and you know what, I'm actually not ready to do that yet. I want you all to take a look at this. We have subtraction, right? So I can do these individually. But the first one is a fraction, and I haven't taught you how to do that, right? Like how to do derivative of a fraction. Same with this one. So to start this problem out, what you're going to have to do is see this. This is the same as 1/5 times theta squared minus 5 times theta to the negative 1. That's the very first critical step for the problem, is to see that. Do you all agree that taking some variable squared and dividing by 5 is the same as multiplying by 1/5? It's like we can like push this 5 out on the bottom in front and make it 1 over 5. That's what I'm doing there. You see that? And then on this one, all I did is I said, hey, my variable's down the bottom. I'm going to bring it up top. So I brought it up as a theta to the negative 1. Theta's like x, right? Theta's just like x here. Now I'm going to do them individually. So I have the 1/5 times this. So I'm going to bring the 1/5. I'm taking derivative now. 1/5 comes for the ride. The derivative of theta squared is what? What's that? Okay, so yeah, just the theta squared though. The 2 comes out, right? 2, and then theta, right? Theta to the first power. I'll turn it into 2 over 5 on the next line. And then I have minus, the 5 comes for the ride, and then times what's the derivative of this? Negative, I'm going to put in parentheses, negative what? Negative 1. Theta to the negative 2. Right? The power comes out in front, then you subtract 1 from the power. Is me using like a different notation, different variables, is that kind of messing you up a little bit? I'm trying to mess you up a little bit because you have to get comfortable with like other notations. Okay, this becomes 2/5. Okay, 2/5 there, and then theta. And then over here we have 2 negatives become plus, so plus 5. And then theta to the negative 2, right? I'm going to write that as a theta squared on the bottom. Or you know what, I'll leave it as theta to the negative 2 on this line. On the next line I'll write it like that. That's my derivative. One more little thing here on this. Just the way you say this, right? This is the derivative of y with respect to, not x, to theta. Theta. Oh, theta. That's the way you say that, the derivative of y with respect to theta. If you have an equation that's solved for a variable like y, and then the variable, the independent variable in here is theta, then if we want to know the rate of change of y with respect to theta, we write it this way, and then we apply our rules. One last example, we'll call it a week. Yes? Find the equation of the tangent line to the curve y equals x to the 4th minus 3x squared plus 1 at the point 1, negative 1. Okay, so we're going back to kind of the beginning of things when I was asking you to do this, right? Trying to find the equation of the tangent line to that curve at a certain point. So I'm going to go to my graphing software here real quick. I'm going to graph this. Y equals x to the 4th minus 3x squared. Shit, that's all messed up, isn't it? Plus 1. What did I do? There we go. What the hell? So there's the graph of that function. And I'd like us to go to the point 1, negative 1, which is that point right there, and I would like the equation of the line that's tangent to that curve at that point. So if you're trying to find the equation of the tangent line, you need a point, and then you need the slope, right? Do we have the point? Yes. Do we have the slope? No. Where do we get the slope from? The derivative, right? The derivative. But now we don't have to do a limit anymore. We just do our formula. So I'm going to now do, all right, let me figure out what the derivative of this. Watch my notation. I want to know the derivative of y. I'm going to write it like this. I'm taking that equation. I'm going to try and find its derivative. So I'm writing y prime. And now I'm just going to use my rules. I have 3 terms, 1, 2, 3. So I'm going to differentiate each one using whatever rule I need. The rule here I need, 4x cubed. Derivative of this, minus 6x. Derivative of 1 is 0. That's my derivative, right? This formula will give me the slope of the tangent line at any point I want. Right? So now what I say is, all right, well, at x equals 1, that derivative will be, do y'all know why I'm using x equals 1? Because I'm trying to figure out at this particular point, right, when my x coordinate is 1, I want to know what that derivative is. This is like a master formula. That gives me the slope of the tangent line at any value of x. The x I'm interested in is 1. So I now plug in, that would be 4 times 1 cubed minus 6 times 1, and that's just what? Negative 2? The slope is negative 2, because that's 4 minus 6. And that means I have everything I need for the equation of the line. Right? I have a point and I have the slope. So I'm going to use my formula that we started this class with, that one right there. I told you it would come into play a lot. I'm going to use that formula. Y minus, what am I subtracting here? What's y1 for me? Negative 1. So y minus negative 1 equals the slope. What's the slope? 2. Negative 2. We just found it, right? Negative 2 is the slope, right? That right there is the slope of my tangent line. And then I have x minus the x1, which is the point over there, 1, the x coordinate. This is y plus 1 equals negative 2 parentheses x minus 1. That's it. That's my equation of my line. If I type that into Desmos, I should expect to see a line that's tangent to that curve at that point. So y plus 1 equals negative 2, x minus 1. That's it. You got it. You'll see it? Yes?
You don't want us to simplify that?
Like isolate the y over here?
Yeah.
No, you don't need to. I mean, you can, feel free to, but I don't need it because it truly is an equation. That is the equation of a line. So, all right. So what we've done today is we've kind of really opened up the universe of what we can take the derivative of, right? But we're still very limited, right? You can start packing up, but I'm going to kind of give you a preview of, like next class, we're going to come in here and I'm going to ask you the same thing. I'm going to give you a function, something like this. And I'm going to ask you for the derivative. And you're going to look at it and you're going to go, well, wait a minute, I don't have addition or subtraction here, do I? So I can't do them separately. What I have here is multiplication. So the natural question would be, can I just do the derivative of each one and multiply, right? Can I just do the derivative of this? What's the derivative of that? 3x squared times, what's the derivative of that? Cosine x. That's natural for you to want to do that, right? And it's going to turn out that this is completely wrong and that we cannot do that, and there's a whole rule we have for it. And that's really what makes calculus get more and more complicated, is that doesn't work that way. So that's next class. We'll do product rule, quotient rule, and then next week we start chain rule. So make sure you're here, or at least watch the video if you're not for next week. All right? Okay, everyone, have a great weekend. Quiz on Tuesday. Quick quiz. 5-10 minutes, nothing more than that. Do your homework.
question on that last problem?
Yeah.
Where you took the derivative. I see.
Like help over 10.